Yep. Well, thank you guys for joining. I'm Paulo Garcia. I do business development for Trial Labs. And this is the actual agenda for today. Alan, you can. There we go. So first, we're going to do an introduction to how to use machine learning techniques to optimize costs. And then we're going to be diving on some real case studies with some actual results to exemplify what we're doing. Then we're going to provide some tips on how to start this, how you guys can get started on how to implement these things on your companies. And finally, we're going to be doing a Q&A session where we're going to be answering some of the questions that we have been gathering on social networks and those questions that also arise during the presentation. So, Alan, all yours.
Thank you, Pablo. So we get started with the main presentation, how to optimize costs with machine learning. I'm Alan. I'm the CTO and partner of Trial Labs. I have close to a decade experience working with machine learning and AI across different industries, mainly based on doing consulting from Trial Labs. So we have all seen it. AI to reduce costs has repeatedly made headlines. Here we have some examples. Chatbots and how can they reduce customer service costs, chatbots saving $8 billion, chatbots reducing costs, how much money can chatbots save you? So the reality is that we are actually not going to talk about chatbots. In the last few years, many people have confused like AI for cost reduction with chatbots, and that is actually a mistake because AI is a lot more than actual chatbots. So there is no one single solution as of reducing costs using AI because the problems are unique per company and per industry. So as the problems are unique, the solutions also need to be unique. So we need to think kind of outside the box. And AI and machine learning, terms which we use kind of interchangeably here throughout the webinar, can be helpful in very unexpected ways. For example, right now we are having this webinar thanks to the infrastructure of the internet. So a lot of this infrastructure runs in data centers. For example, those powering the Zoom application which we are using, or if you are going to watch this later, then the video streaming site in which you're watching is powered by data centers. So why do I bring this problem of data centers here? What does it have to do with AI and cost savings? Well, a couple of years back, this actually made headlines. So Google using DeepMind AI to cut data center energy bills. And in this case, it's interesting that they got a result of an overall 15% reduction in power consumption, thanks to efficiency in cooling gained with AI algorithms. And it's, at the scale of Google, these are really huge savings. I mean, gigantic savings. So I like this example a lot because it's a very non-obvious application. Sometimes the process of AI and machine learning is a little bit like science, in which you invest a lot in some area, or you're doing research in some area, which seemingly doesn't have a lot of applications, but then applications start to pop up in very unexpected places. So in the rest of this webinar, we'll focus on cost reduction. And we'll show you that you don't have to be Google to be able to spot these opportunities and take advantage of those in your own companies. A little bit of an intro about Trial Labs. We are a machine learning consultancy company. That means that we help other companies throughout their machine learning path or machine learning journey. We specialize in solving several problems using machine learning as a tool. So the idea is to help these companies throughout all the phases of machine learning development, from discovering the opportunity, R&D, to make sure that everything, what is possible to actually achieve, to actually putting these systems into production. We have been in business since 2009, mostly focused on the US market, but lately we've been expanding. We have offices now in Luxembourg, in Europe, and we are also tackling some international clients. Here are some of which are listed here. Right now we are about 53 people, and our team is based in Montevideo, Uruguay. Here's a picture, a beautiful picture of our team before social distancing was even a thing in people's ears. So about our areas of expertise, so what kind of tools or what kind of categorization of problems that we solve can be made. We are problem solvers by nature, and basically we kind of categorize the problems in these three verticals. One is computer vision. So how to understand images and videos with machines, then natural language processing, understand and generate text at scale, and then forecasting models, which is kind of a big bag of things. And we've been doing a lot of work here, especially lately on pricing. This concept, these three categorizations will ring a bell really soon when we speak at the cases. So you'll like have examples of concrete uses of these. So let's get started with something very simple, the profit formula, the magic profit formula. So to make profit, we either need to focus on increasing revenue, or we need to focus on reducing costs. This is like very, very obvious. But I want to bring this because it's interesting that you don't necessarily have to think about increase these or decrease these, because something that actually works for lowering your costs can actually indirectly also help you increase revenue, or at least in the longer term, have a positive impact on the revenue. And so these things are not like completely separate things. And you'll see that especially in AI and machine learning initiatives, we'll see that there are several side effects that have a positive impact. And we'll focus more on this webinar on the initiatives which materialized, kind of came to be because of the need to save costs, but then we'll see also what positive impact they had overall. An interesting distinction we have to make is between the concept of cost cutting and cost optimization. So we should differentiate between these two because we really mean different things. Cost cutting is a short-term solution. Cost cutting is an immediate reduction or elimination or rationalization of costs. And cost optimization or cost reduction is about improving performance in the longer term. So cost optimization is about being more efficient while getting to the same outputs process that is not really necessary. Or maybe it was, but not that much. Of course, I mean, cost cutting is still a viable solution and a necessary alternatives, but AI and machine learning are not going to help you with this. So the main objective, of course, of this webinar is to transmit the ideas of initiatives that came to be for decreasing direct costs. But also, what if we think about solutions that not only decrease direct costs, but also focus on optimizing the processes? That also means that they can reduce indirect costs and also help you to increase revenue. So the whole idea of cost optimization is to make operations more efficient. It's a business-focused discipline about how to actually spend smarter and maximize business value. What are the advantages of using machine learning for cost reduction? Well, first, you can kind of have a decrease in manual errors. There are some processes whenever you have humans in the loop, they have some inherent error component. With machine learning, sometimes it's very possible to get more consistent outputs. Machine learning never gets tired. It always does the job. It never skips the job. Then we also have some processes that can be cheaper to audit. Like in some cases, machine learning can output the solution much, much faster than humans can. So this means that you will be kind of forced to have some continuous evaluation of how the processes are working, which is really, really hard and expensive to do with humans. And also the cost of a general audit will be lower because in the case of machine learning, you can store which machine learning model produced which output at which time. And then you can go back and see, okay, what was exactly the cost for this particular output and correlate that to a specific machine learning model. Then machine learning model can scale. This is hugely important, and for many companies, it's the difference between profitability and not being profitable. Machine learning, nobody likes doing repetitive work, and machine learning excels at these kind of solutions. We actually let people focus on more important, more high-level tasks where they can use their creativity instead of doing repetitive work. So we're not talking about letting go of people and this concept of people out of jobs. This is nothing like the case. The idea here is to leverage people where they have the most impact. So where they can create the most business value and help them not do any repetitive work. And also, machine learning enables you to learn more about your own processes. This is really important because, like, I kind of skimmed at this before, but when you implement a machine learning solution, you'll be forced to compute all sorts of benchmarks of how the machine learning algorithms are faring. And that also means that you need to compare them against humans that did the job before. So you also have a benchmark around how humans were performing, and you'll understand a lot more about algorithmic performance, how to perform these tasks at scale, and what are the actual bottlenecks for accuracy. You'll understand your processes better than you ever did. So a little bit of a warning to kind of demystify, again, ML, machine learning, AI, we use the terms interchangeably. It's basically learning from experience in order to produce better and better results. And I want to say that it's not a silver bullet. It's not that machine learning is magic and it will solve all your problems. Machine learning is a tool. So as a tool, it needs to be properly integrated into a business solution overall. The second thing that I want to highlight is that machine learning is an ecosystem. That means that there are a lot of tools and a lot of ways to actually do machine learning, as we say. But it also means that for machine learning to work, there are several requirements and it needs buy-in from several stakeholders. So machine learning will affect different parts of a company, different teams, and they all need to be aligned. If this doesn't happen, then machine learning will not be the best path forward. So also the data must be there. If you don't have data, or if the data is not in a state that can be used, then we also have problems. So this is what we mean by machine learning is an ecosystem. It's just like you just put an algorithm and it does the work. It has many, many components around that. And in what follows, we'll try to make the point that machine learning is indeed a worthwhile investment for cost reduction. So after this intro, this kind of generic intro, let's discuss some concrete use cases in which we have worked with real clients producing actual real results. The idea here is to kind of illustrate the think outside the box mentality and how these opportunities can manifest and appear from different parts of companies and have a positive impact overall. And of course, if you are one of our clients who has participated in these cases, we want to say hello and thank you for giving us the chance of working with you. Okay, case number one, pricing secondhand luxury items. So one of our largest clients is an online retail shop based in the US, secondhand luxury. So they are a consignment shop. This means that when people want to sell something, I want to sell my t-shirt, so then I consign it to them, they grab it, they receive it on a warehouse, then they go through a process, and then the t-shirt gets published in the e-commerce. This is a really big operation in the sense that they have many, many thousands of items processed per day. The idea here is that when the item arrives, it goes through a process, and the process has several steps. A key part of the process is actually I receive a clothing, for example, or jewelry, watches, shoes, and I have to set a price. Okay, I need to set how expensive will this be for me to actually publish it on the website. So this is really challenging because it's not like we sell only one brand of t-shirts. This is secondhand business, so the variety of items that arrive to the warehouse is really, really enormous. And people need to know how much each item is worth, and the variables that affect the price are many. For example, it might be that a designer is generally more expensive than another designer. It can be that a collection of a designer is more expensive than other collections of the same designer. Also, the type of item, shoes are differently priced than t-shirts and pants. Then also the condition, if the item is like in pristine condition, it might be more expensive, that it has some wear and tear. So it's a really complex problem. And the way the client solves this is by actually having people that receive the item and they know how to price items. So these people are called copywriters, and they have a lot of knowledge of fashion trends and different fashion garments, and they know how to put a price to them. But every time one of them leaves, then they have to hire another one and they have to retrain. And it's not simple. It's a complex process in which the person gets better and better with time. But our clients came to us because the process of putting the price was too expensive. So if they wanted to scale, they needed to have more people, and that will be complex. So the pain points of this manual process, it's a very repetitive task. You only get items and you need to set a price. So the output is just really one number per item, but you need to do that for thousands of items each day. Then the job of the copywriter is a job with a fair amount of rotation. So people kind of get bored after some month and they leave. And then that means that you have to hire another one and train it and retrain it, retain that person, because if not, it's expensive to get more people that can do the job. Also, we have the inconsistency problem. So some people price differently, and there might be that two items came that are very, very similar, but they went to two different people that set the price, and one said price X and the other said price Y, and these get published in the site. And if a person finds out, like, why do I have two items that are the same and they're priced like very differently? That's a problem for customer experience. And of course, as I mentioned before, the scaling bottleneck. I mean, if we need to scale the operations in getting more items, we need to hire more people. That's the only way out of this problem. So what we did here was actually implement a flow in which the price was set by a machine learning system. So to get the pain out of getting more people to price, we actually took all the pricing decisions that were made in the past, and we learned from those pricing decisions what's the optimal price for each new item. So a new item arrives, we say, okay, this is this type of item. It's a pants, it's t-shirt, it's a purse, it's shoes. Then this is the designer. Then this is the color. This is the type of fabric. This is the collection, and so on, so on, so on, and so on. And this, with all these kind of features, the algorithm was looking at what people did set the price, how people set the price in the past. And then based on that historic information, we can learn a price for a new item that the algorithm has never seen. It's interesting that for this, we also used computer vision, in the sense that we took, so for each new item that arrived, one of the things that was key in determining for how much I should sell these is finding visually similar items that I have in my collection and understanding how those were priced. So it's a solution that has components of machine learning in the sense of computer vision, looking at similar items visually, natural language processing, because I needed to read the description of the item, the items, and get information from that description, and also the categorical information such as type of fabric, type of designer, etc. So all that information was baked into a model. We could output predictions for price. So what costs did this approach kind of save? Okay, the pricing experts, the copywriters. Now we don't have to hire as many, or they can do more with less. But also the indirect costs that this solution affected. We, down the line in the entire workflow of the publication, they have the QC experts, which they actually know a lot more about fashion trends, and they check the prices set by these copywriters as they receive the item. So they have this team of people that actually adjusts prices based on their more advanced knowledge and more broad knowledge of fashion. So these copywriters also had, these QC experts also had to do less of a work because we increased the consistency in the prices. Also, the revenue increase in this case comes from the fact that some of the prices that the algorithm ended up setting were actually better than the prices set by humans, in the sense that as we gain consistency, sometimes items were sold earlier, but they were sold at more expensive prices. So apart from this, we also gained the chance to scale the operations. So how does this translate into money, or something that is kind of eye-catchy for people who want to invest in AI? We calculated that the cost savings, the direct cost savings attributable to this price automation solution are about $10,000 per month. This is, of course, again, direct. The actual indirect savings is much broader, because we are talking about retention of people, training people, hiring new people. And this is with 62% of the catalog completely automated. So whenever you consign an item, it's if it's within this 62% of the catalog, it will get priced automatically. And what we did is basically reduce the time that it takes for people whenever they receive an item to process it. So we shoved off 20 seconds that they use for pricing, and each item takes 20 seconds less. And if you translate this to money, it's 10K USD per month, which is very significant. And of course, as the operations grow, this will also grow. Case number 2, same retailer. one of the other pieces of the puzzle and parts of the process is that apart from setting a price, they need to write a description of the item. It's not like the manufacturer provides a description because this is secondhand. So we receive a dress, for example, and then it says mini cocktail dress featuring cowl neck, open back, belt accented waist, blah, 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 blah. So somebody needs to go look at the garment and type the description. And this is really time consuming. So again, pain points here, repetitive task. We have people just looking at items, describing what they see. Expert involvement, because I wouldn't be able to write a description, only very basic things like the color or the type of garment or the shape. But there are all these nuances of the fashion industry that people need to just type, and you need to know what you're speaking about to actually accomplish this. If you're typing a lot of descriptions, you'll for surely make typos and grammatical mistakes. This is like unavoidable. You can have a spell check, but then people they need to do the work fast. So this is really important. Sometimes in some specific niche, there's some inconsistency between people. They kind of write different things, like, I don't know, the type of neck, what is actually a V-neck? Maybe there's something that kind of looks like a V-neck, and for some people it's a V-neck, and for other people it's another type of neck. We have these cases. And of course, again, the scaling bottleneck that this process entails. So again, as we did with pricing, we suggested to automate the descriptions with machine learning. And in this case, we created an algorithm that it's a two-part process. We took all the past descriptions that people have typed for the past items in the collection. We extracted the most important bits of the description, for example, like the tags, what type of fabric, what type of color, what type of collection. Those were extracted from the paragraph that people had typed in the past in order to kind of make a bulleted like description. And then we trained a computer vision model, actually several computer vision models, that could actually look at the images of new products and output these tags automatically. So this kind of model was able to see a picture of a dress and then output, okay, this is a V-neck dress, it's orange, it has this zipper or this enclosure or this, I don't know. And this was also a very, very important part to automate. In this case, the direct cost, of course, again, the people who are actually typing the descriptions, they have more time. They can do more with less. The warehouse storage, because if we are typing the description faster, if we are processing items faster, then they don't need to be stored as much because they will be sold earlier. Again, the QC experts that corrected the prices, they also corrected the descriptions if they saw errors. So we kind of normalized the work for them. And also, it's interesting that the revenue increase that this part of the automation has can come from actually improving the customer experience because they see more consistent descriptions along the site. Also, we do have tags now, so the search can be improved, and of course, operations can scale. And it's also interesting to highlight that, as I said before, there are some niches in which people kind of disagreed in what exactly is this. So is this a V-neck or is this a X-type neck? In these particular cases of images, it's kind of hard to tell and such. Well, the fact that we implemented machine learning to process the images could actually highlight the client, which were these niches in which the people were kind of doubting. There was no clear criteria for these kind of garments. So this actually made it in turn possible to improve the taxonomy even more and make it better so as to de-ambiguate these areas of doubt, so to speak. Translating into money, we kind of saved 39 seconds on average for each processing item at 60% of the catalog automated. Of course, this is increasing because we're still working with this client. And this translates to an actual direct savings of almost 20K per month. And again, this is only increasing and the indirect cost savings are much, much higher. Another piece of the puzzle, whenever some item is published as it's secondhand, we need to retouch the images. So we have a photographer on the warehouse that actually puts the clothing on a mannequin and they take pictures. But these mannequin pictures, they don't get published as they are. They need to be retouched by a photo editing team. So before they get uploaded to the online catalog. For what kind of retouching they do, for example, they align, if the item is not perfectly vertical, then they move it, they center it vertically, they crop it to the appropriate length, they do background removal, as in the sample image that we have here, they do color adjustment, the mannequins have like shoulder joints, which they kind of erase with Photoshop, so it looks it looks better. And then the mannequin is stepping inside of above a base, and that base gets erased with Photoshop. So all those kind of editing gets done for each single item that gets published on the site. And again, it's a repetitive task. It's just like photo in, photo out. It needs to be done by expert on using Photoshop, which is costly. I mean, there are many thousands of images processed each day. So we have high cost of the editing service. And then after the photos are sent, we send a bunch of photos and we get them back, but the process takes 2 days. So it's 2 days that I have my pictures being processed that I could have published my items in the site, but I didn't. And again, as I want to publish more items, this will be a productivity bottleneck. So what did we do? We suggested that we could automate parts of the editing process with computer vision techniques. So we designed a mixture of classical and machine learning based computer vision techniques in order to process these images automatically. We learned from the way that photo editors had been doing their job in the past. We have like sourced image, raw image, and then we have the edited image. So from that, we kind of learn how to rotate images, how to adjust, what's the actual cropping that we need to make. We also learned some very interesting techniques, how to delete the mannequin joints and how to remove the base. This is all done with computer vision techniques and some other interesting models. What kind of costs is this affecting? First, we have the retouching experts, this third-party team. They need to do less work. They can do it faster because they have less images to process. Indirect costs, as I said, the warehouse, if we can process the images faster, then the garments will be published faster and they will be sold faster. So they will be not just lying around in the warehouse without being published. And then, of course, it helps scaling. So translated to money, we are processing around 2010K images per month. And this is a direct cost savings of $20K US just by doing this process. And it would be nice by itself, these kind of savings, but we also have a reduced turnaround time of 2 days to 30 minutes. So everything that took 2 days from sending the pictures to getting them back, now we have automated in a machine learning pipeline that takes all this batch of images, and in 30 minutes, you have all the results. And the acceptance rate is really, really high. I mean, plus 90-something%. I don't remember exactly, but it's most of the images are done right automatically. And those that are not can be done by the humans. So here you can see like it's not only about direct cost savings. There are other indirect cost savings, such as these, that are very important. And sometimes it can be even more important than the direct cost that you're saving. E-commerce category trees. So we have Mercado Libre, which is like the eBay of Latin America. It's a very, very large e-commerce site when people can actually sell whatever they want. And the problem they had is that they had the category tree. So in order for people to publish an item, they had to select the category that the item was going to be published. I don't know, mobile phones, iPhone 9, and then I published my new iPhone. The problem that they had is that these trees were like really, really huge. We are talking about trees with more than 12,000 nodes, 12,000 leaves, and that is one per country. So we are talking about 12 countries, and each of those had their own tree, which was maintained independently of the others. And what was happening is that people were publishing items in the site, but whenever I publish an item, maybe I don't find the category that I'm looking for because my item is new. So for example, I don't know, iPhone 13 comes out, and then I want to publish my iPhone 13, but nobody in Mercado Libre had created that category. So where do I put it? I just miscategorize it. And then what they get is a bunch, really many hundreds or thousands of products which had the wrong category and for which the correct category does not exist, okay? They actually have teams of, I don't know if it was close to 20 people that were, whose daily job was actually to run queries on the actual trees and see what items were published recently and which ones did not have like the right category for them, and create that category and move them to that new created category. This was a very, very painful job, but necessary, because the miscategorizations, like having the wrong category for the items, makes that it's not as easy to find if you do a Google search, for example, and this has a real impact on their business. Again, repetitive tasks, you're running queries, creating categories, moving items, and that's what you do every day. And again, we're talking about huge volumes of data, so much more than any human can handle. So they came to us, and what we built is an AI assistant for categorization. What this ended up doing is that every day we went over the items that were being published. We extracted some interesting patterns from the title descriptions and also from the things that people were searching. So the visits of the items and the searches on the site, as well as the item title and description, all went into a machine learning model that could look at the publication and see, okay, I see several things that are being called iPhone 13. I suggest you to create an iPhone 13 category, and you should move all these items. And I have prepared that, that movement for you. Do you accept? This was kind of what we built. So, of course, costs directly the tree maintainers. We could do a lot more with less. They can work much faster. The indirect cost, again, the miscategorized items were being moved or suggested to move in an automated way to the correct category. And if the correct category does not exist, then we suggested the creation. So there's this like bag of items in each node called, like, I don't know, mobile phone, iPhone, Samsung, blah, 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 others. And these others had like 60% of the items. So we also reduced the number of items that were in this others category by a lot. And this really affected their sales and the customer experience. And the SEO, of course. So that's kind of how revenue could increase with this. What we got to was a 5x increase in operator productivity. And we were categorizing automatically more than 25,000 items. And this was a couple of years back. I guess now the number is much, much higher. And remember, this was done independently for 12 countries. So the same solution could apply the exact same to all these countries, and instead of hiring very different teams. Our last case is Food Levelers, which is a world's leading provider of individually designed custom orthotics. So I don't know how many of the audience right now has flat feet. I have flat feet, and I didn't know that it was like such a big deal, in the sense that flat feet with time can cause a wide variety of problems. It can cause a neck ache, it can cause low back pain, knee pain, unstable foundation. And if you don't do anything about this, with time, it will get worse. So we are lucky that we have Food Levelers as a client, and we learned about these things. So how does the orthotic manufacturing process works? First, you get your feet scan. So you go to the chiropractor or to another doctor, and they have a scanner in which you put your feet, and this produces an image. So with this image, there are technicians in the Food Levelers side that actually know a lot about human anatomy. And just by looking at the feet scan, they can, plus of course some additional information like the age of the patient, the sex, what kind of shoes they use. So all this gets into their mind, and seeing the image of the feet and the pressure points. So for example, in the left, you can see that they definitely have a flat feet, and the right is kind of okay. So based on that, they select the appropriate blank for the corrections. They select the appropriate corrections, and then can position them wherever they need to go. This then goes down to the production line, and you get one orthotic like that. And I actually have mine over here, so you can see that it has corrections placed in specific sites. And this is actually custom designed for me based on my own scan. So thank you to Foot Leveler for providing this to me. It's been great so far. You are easing and making my life easier and not having any knee pain at all. So yeah, the pain points of this is that like the mind works faster than the mouse and clicking around. So it's a repetitive task, yes, but you need qualified experts to do this. It's not like you can hire me and I can know how to build orthotics. You need to have people that have actually studied this. And these experts are hard to find. And there's a lot of work for them. So again, if you need to produce more orthotics, you need to hire more experts. And it has some limits. So what if we could do something that actually helps the technicians work faster and produce better results? Instead of just clicking around and seeing and putting the actual corrections where they need to go, what if we could feed them something that is mostly right most of the time, and they just would need to check whether that solution is correct? So that's exactly what we did. It's kind of an AI-assisted manufacturing system. And incrementally, we are teaming up with foot levelers to help their technicians be more and more efficient. In this case, based on the thousands and thousands of images that we had of feet in the past, we kind of learned what kind of, how to do the appropriate measurements based on these images, how to position the corrections that need to be positioned, and what kind of corrections are needed. And the system kind of learned how to perform these tasks. And we are adding more tasks with the help of the foot levelers people that have been great at this. We are kind of helping them add more tasks to the automated system. It's like the system encodes in some way the knowledge of the experts and produces a smart selection of defaults. So most of the time, the technicians have to look and say, yeah, this seems okay, next, or no, this should be a little bit up. And then that information gets fed back to the algorithm so that next time it will make a better decision. Again, costs that this solution affected, the technician's time, now they can process a lot more. Human errors down production line. So it happened that sometimes the technician made a mistake, and this was spotted by somebody else down the production line. In this case, the algorithm is very consistent. So we are hoping that by lowering the work that the technician has to do, we can actually produce better results. And of course, increase the production capacity down the line. So we increased their productivity 27%. This was measured by them. And again, this was of the first engagement that they had with us. And now we are engaging in other steps of the pipeline. And we hope that this number will be even better in the future, in the very near future. So after this kind of walk through some real cases and real cost reductions, how can we get started with this in my own company? It's the $1 million question, maybe literally $1 million question. So a little bit of what we try to convey with this example is that you need to kind of search opportunities at every level. It's existing or new processes that, with the help of machine learning, could provide business value and make operations more efficient. I need to go transversally through the company because, like as we have seen, it's not obvious every time where the savings will be. Go layer by layer, and this is where the business knowledge that you have or your own company will shine. I mean, we all good with machine learning. We love doing machine learning, but you have the business knowledge. And without that, it's very difficult to spot these kind of opportunities. So again, look for high impact projects in the sense that you need to make the investment worth it. Don't overdo it by going with the most ambitious projects first. Consider the return of investment and the difficulty of making the initiative work. Here are some tips we want to share of how to actually spot the top opportunities for doing machine learning and automation. Of course, this is depends on the case, but kind of a rule of thumb, okay? So first, if you have a complex rule-based solution or heuristic, like you have a process that is being solved with complex heuristics, this is a very interesting topic because complex rules or heuristics have a very high cost of maintenance. So this kind of shouts, try out machine learning. You always should prefer, or kind of nearly always should prefer, machine learning over a complex heuristic, in the sense that generally machine learning will work better than the complex rule-based system or complex heuristic. But not only that, in the sense that if the data changes, the underlying data changes, the machine learning solution can retrain, and this data can be fed back, and the machine learning solution will improve. Whereas if you are dealing with heuristics, you'll need to go back yourself and change a bunch of rules. Maybe that bunch of rules is actually thousands and thousands of rules. So machine learning, you kind of get that for free once you have a baseline setup. Again, in the case studies, we have seen it, but tasks that are very, very repetitive, nobody actually likes doing those kind of tasks. So think of whether machine learning can be applied here. This is interesting. I think that technology is at a point where anything that you can think of, or I'd say nearly anything that you can think of that would take a human less than a couple of seconds, say, for example, less than 10 seconds to a person. If you have people doing these kind of operations repeatedly, then there's a very, very high chance that this can be automated. So down a production line, routing, I don't know, routing documents from one side or from the other, kind of visually inspecting something and sending it to QC or sending it to the final client. I don't know, anything that a person just looks, thinks for a little bit and then decides, then there's a very, very high chance that this can be automated. So think if you have people doing this kind of work repeatedly in your company. Again, anything that involves expert knowledge, we are not talking about replacing the experts. That's probably never going to happen. We are talking about making the experts more efficient. So the experts are expensive, they're hard to get. Best things we can do is maximize how productive they are and make them happier at their work. So if we can use and leverage machine learning to do this, then great. And the experts can solve the harder cases while machine learning solves the easiest cases or the majority of cases. Again, we have seen it in the cases. Anything that kind of is a productivity bottleneck and doesn't allow you to scale. And if you need consistency, then machine learning might be a way to go because we can reduce the number of errors. So at least you'll have no error because somebody was tired, okay? So the kind of the takeaway here is that you need to start small, but you need to start. I mean, think of how you will be in a few years from now if you don't get started now with AI. How extremely competitive the markets are. And it's something interesting, but reaching maturity for AI, it's something that takes time. So every organization needs to learn a lot and needs to practice and needs to figure out their best way of reaching AI maturity. So it's better to start now than to just wait till everybody else does it. And again, don't be too ambitious from the beginning. Do baby steps, work on prototypes. There's this idea that I like a lot that says like a prototype is always a success. Because even if the prototype does not solve the problem that it needed to solve, even if that happened, you'll learn a lot about why that wasn't the case. And you'll prepare yourself for the next prototype so it can be even more successful. So for example, the data was not there. Data was not in a format that was usable. You had governance issues. You had misalignment between different stakeholders. All of these you'll learn by trying to come up with the first prototype initiative. So it's really, really valuable. And again, you have to measure all the time and prove value to different people in the company. So establish clear goals and business metrics from the start and make sure you track those through time. This way you have everybody aligned much easier. And before finishing, I'd like to leave you with a testimonial from Food Levelers. So again, one of our cases we really liked because we are ongoing working with these guys. They have made our life easier, not only because we're having fun doing machine learning, but we can walk better. So they said, Trilabs has made implementing AI so simple. Our updated software has become so much faster and easier to use. Our operators have increased their throughput by 27% so far. Thank you so much for your help. And the key takeaway here is that don't be afraid to invest. It might seem that it's costly. It can be costly at first. But as we have repeatedly seen, these kind of initiatives can pay for themselves fairly quickly and prepare you for much larger scale of business. So we are here to help you. We love to find opportunities using AI together. We can do this with your business knowledge and with our knowledge of machine learning. So if you'd like to get started with AI, don't hesitate to contact us. And thank you for your attention. And now we have time for questions.
Yep. Well, thank you, Alan. And actually, just to do an icebreaker here, we gathered a couple questions from our social networks.
Okay.
And the first one would be, how can I tell how long it takes to do a project like this?
Great question. Like in some of the cases that we have seen, some initiatives, the initial value was proven within a few months or even less. In the case of food levelers, like an initial 1 month engagement was enough for them to know that they had to invest more, which was great. But it's very difficult to tell beforehand because like the problems are unique, the industries are unique, the companies are unique. And what we like to do is like, in general, software estimations are hard, but machine learning is even harder because you have another dimension. You have the dimension of data and whether the algorithms are up to the task and whether data is up to the task. So there's a lot of variables at play here. What we usually do to kind of mitigate this risk and not being generating a sinkhole of just pouring money and not getting results, or promising, yeah, this takes 6 months, and then at the first month, no, this can't be done. This can actually happen in some companies. So what we do to mitigate that risk is we propose to engage on a kind of phase 0. The phase 0 would be like the technical validation, where we try to get the mini prototype, the most essential thing in order to understand the state of all the pieces that will be involved in this machine learning initiative. And if everything goes right, after the phase 0, we will have, the phase 0 can be from a few weeks to a month and a half, I don't know, that depends on the actual case. But after the phase 0, we will have a much better idea of the business problem. We'll have business knowledge that was transmitted by the client, and also how the data is looking like, who in the company is responsible for what, and the complexity of the problem. So after this phase 0, we can be in a position where we say, yeah, given our past experience and knowledge, we think this can be done in X amount of time, or this can be done iteratively, and these are the performance bottleneck that we will hit, et cetera, et cetera. So it really depends. We like to engage on a first phase 0 to mitigate these risks.
Perfect. So we have one more question here by Sebastian. He says, can you give a sense of an investment that was behind some examples that was shown, like expert fees plus technology, etc.?
Like what? Expert fees, you mean?
Expert fees, technology, etc.
Yeah, that's actually depending on the actual client and the size of the opportunity. Like if you'd like to know some concrete numbers, or you have some idea in mind of a concrete project that you'd like to tackle, feel free to contact us. But what we can say is that in many of these cases, in practically all the cases that we have seen today, the initiatives pay for themselves in the terms of savings. So again, this is an investment on the client's part, but this has a return of investment, and the cost is justified, or more than justified, in the sense of it gives potential for scale, and it gets rid of some costs that are recurrent. So if you like to discuss concrete numbers, we can do that with a more concrete proposal. No problem with that.
All right. So next one is, the solution you offer is only a software solution, or it can be a combined with physical machine, for example, a box sorter?
Yeah. In general, yes, it's a software solution. Of course, the software needs the hardware to run. What we do in general is to leverage the infrastructure of the client. So if the client is using AWS, GCP, Azure, then we can do the deployments on their own infrastructure cloud, hooking up to their own databases and outputting the results in another database or in another file server. But yeah, I like to say that we are engineers first. in that we take production integration really seriously. And all these production pipelines that we have built, some of which we have shared in the cases today, are processing thousands and thousands of images per day, or thousands and thousands of product descriptions per day. It's all hooked up into the production infrastructure provided by the client. If the client is not technical, or they do not have an existing production infrastructure that they can use, we can actually set it up in the cloud provider of their choice. That will be no issue.
Yes, but apart from that, he's asking if we also hook up with physical machines. If we have the ability to hook with physical machines to do some of the projects too.
So not cloud, like on-premise. That would be the question.
Like a machine, like machinery, or maybe.
Oh, okay. So, all right. Yeah. If we do hardware, no, we don't do hardware. We have a couple of partners that can manufacture hardware for custom needs. We can get you in contact with some of those companies if you're interested. But yeah, it's like we wouldn't have experience in actually doing a robot in a production line. But we can do the software part of the robot, and the robot can be manufactured by somebody else. I guess that's kind of the question. And if you have on-premise infrastructure, like your machines are physical machines, physical servers on your infrastructure because you don't use the cloud, as long as we can connect from the outside world, then we can set up things there.
All right. So someone was asking here if there's going to be the recording of the session. Yes, we're going to be providing that along with the slides that we presented. And another question was if we ever work with the administration or finance areas of companies.
Mm-hmm. Yes, and we are working right now. One of our clients is Allianz Global Investors. So we are working with risk management. I cannot disclose exactly what we're doing for them, but yes, we have worked with finance. Probably not a lot of finance companies, but we are getting into that, and it's a very exciting niche. Yeah, definitely.
Perfect. Well, if anybody has any more questions. We'll give it a couple seconds.
Sure. Bring it on.
Yeah, and of course, if you think of other questions later, you can just email us at hello@trilabs, and we'll be happy to answer. All right. Thank you guys for joining. And again, we're going to be sending this to your emails with the video plus the slides. And happy to have you guys here. Let's keep in touch.
Thank you for your time. It was great presenting this and sharing what we have done in Trial Labs. And we are happy to help anybody who would like to understand if there's opportunities for machine learning in their own companies. We'd like to team up with you and help you on that endeavor.